Solve the following quadratic equations by using the quadratic formula. All right, so to use the quadratic formula, the first thing is you should probably just write it down because students often remember this improperly. And if you remember it improperly and you use it on a whole bunch of questions on a test, you're going to get a whole bunch of wrong answers. But if the instructor sees that you had the wrong formula, perhaps you'll get some partial credit. So at least do that. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what we need to do in order to use the quadratic formula is in the quadratic we want to solve, determine what the values of a, b, and c are. And the way we do that is the general quadratic looks like ax squared plus bx plus c equals 0. So it's just the coefficients off of our quadratic. So in this case, a is equal to 1, b is equal to negative 8, and c is equal to 16. So our solutions here are going to be negative b, so the opposite of negative 8, plus or minus the square root of b squared, which is 64, minus 4ac, so 4 times 1 times 16, and 4 times 16 is 64. Then all over 2 times a, and a is 1, so that's just all over 2. All right, so 64 minus 64 is 0, so this whole square root just becomes 0. So it's really just 8 over 2, which is 4. So it turns out there's only a single solution here, which is the value positive 4. All right, next up here, we have 5x squared minus 13x equals 6. Well, first thing is that the quadratic formula does not apply unless you have your quadratic set to 0. So get that to happen first. And now start identifying your coefficients. So a is 5, b is negative 13, and c is negative 6. So our solutions here would be x equals negative b, so the opposite of negative 13 is positive 13, divided by the, or plus or minus the square root of b squared, which is 169, minus 4 times a times c. So c is negative, so that's going to change this all into a plus. And then 4 times 5 is 20. And 20 times 6 is 120. And then that's all over 2 times a. 2 times 5 would be 10. Now, here's where the quadratic formula really gets difficult because there's generally a lot of reducing that needs to happen here. So let's see. In this case, the first thing I could do is just add these two numbers together. So 169 and 120, that would be 289. So square root of 289. Now, you may or may not recognize 289 as a perfect square. It actually is. It's 17. And so we have 13 plus or minus 17 all over 10. So our two solutions then would be 13 plus 17 over 10 or 13 minus 17 over 10. And let's see what that would be. So 13 plus 17 would be 30. And then 30 over 10 would be 3. 13 minus 17 would be negative 4. Negative 4 over 10 could reduce to negative 2/5. So let's do this. Let's just say it's 3 or negative 2/5. And those are the final answers. Now, because these came out to be integers and fractions, what that means is this original polynomial was actually factorable. Probably would have been a better choice to gone through the factoring process rather than jumping straight in to complete the square because the factoring process is generally a little bit more user-friendly and accurate for answers. All right, let's see what we have next. So 3x squared minus 4x plus 3 equals 0. So that means my constant, or the coefficient a would be 3, b is -4, and c is 3. All right, so my solutions then, x equals -b, so the opposite of -4 is +4, plus or minus the square root of b squared, which is 16, minus 4 times a, which would be 12, times c, which is 12 times 3, or 36, so 16 minus 36, all over 2 times a. A is 3, so that would be 6. All right, so reducing at this point, 4 plus or minus 16 minus 36 is -20, and -20 can reduce to, let's see, so it would be 4 times 5. 4 is a perfect square, so I could make this 2i square root of 5 all over 6. And then the final answer here, what I could do next is, if I notice that there's a common factor of 2 in the numerator, I can factor that out, which leaves me 2 plus or minus I square root of 5. And there just so happens to be a factor of 2 within 6, which leaves me a 3 there. So my final answer then is 2/3 plus or minus I times 5 over root 3.